This is the Yaskawa Servo drive that had the shorted IGBT, and we tested the V high side firing channel. And it's running a motor. Good, good. that run for a little bit. Make sure it doesn't fail again. So far, so good. Good job, folks. You fixed another one. All right, all. Here we are at the house on a nice Sunday afternoon. And let's talk about our hookups to make the Yaskawa model SGDB-20VD servo drive run the servo motor model SGMG-20V2AB. Shoo, that's a mouthful. So here on CN1 connector, it's 50 pins, a D-sub mini connector. On pin 5, we have the VREF input for the speed reference and signal ground for the speed reference. These two pins right here that make that motor run clockwise or counterclockwise and up to speed. I have power supply number 1 of plus or minus 10 volts to a 5 kilo ohm potentiometer going into pin 5 for the speed reference. Now we have to connect the signal ground pin 6 to that same power supply. For the switch inputs, we have a second power supply number 2, and it is plus 24 volts DC and its ground. These two grounds are separate, they're not the same, so don't get them confused. Don't connect them together. In fact, let me write this down here. This is power supply ground number 1, and this is power supply ground number 2. They are separate grounds. The plus 24 volts DC from this second power supply is connected to pin 47. That's plus 24 volt in. We have a P-aught, P over travel, and N over travel inputs on 42 and 43. What they do is you'll have an over travel switch in your machine. So let's say we're moving a table and we don't want it to go so far. We set over travel limits that are input. Let's say we had an over travel switch here and an over travel switch here for P over travel and N over travel. When this switch was opened up, because the table hit that limit switch and opened that switch up, it would stop the servo drive from running that servo motor. And it's called P over travel and N over travel. So we're going clockwise and we over travel, we hit that limit, or we're going counterclockwise and we over travel and hit that limit, and the switch opens up. And I just tie 42 and 43 to ground to deactivate the P over travel and the N over travel. That's positive over travel and negative over travel. To activate the servo drive to run that servo motor, we close this switch right here, servo on to ground number 2, that 24 volt DC power supply ground. And when we close that switch, that servo motor will run. Let's go down and we'll look at the power connections. To power up the drive, we have 2 inputs on RS and T and little r and little t. Now little r and little t, they power up the control. So if you don't want the high voltage to run that motor on RS and T. You just want to power up the control. You apply 220 volts AC single phase to R and T. And you will not have a DC bus out there to run that motor. But if you want the high voltage DC bus to run that motor at about 310 volts DC thereabouts, that's 220 volts AC times the square root of 2, you apply 220 volts AC three-phase to R, S, and T. Now I powered up both at the same time. So I had R connected to little r and T connected to little t, so that when I applied this 220 volts AC three-phase, we brought up the DC bus to run that servo motor, and we brought up the control voltage to power up the control. Now down here we have U, V, and W, and frame ground. Terminal U is connected to A on the motor. Terminal V is connected to B on the motor. Terminal W is connected to C on the motor. And we have frame ground, which is terminal D. I don't have it wrote down in there. Let me write that real quick. So terminal frame ground goes to pin D. So we have pin A, pin B, pin C, and pin D on that servo motor. Now that is the voltages that power up the drive and the outputs from the IGBT to run the motor. Now I've got to say something about this frame ground to pin D. If in this system, if I don't have that connected, that motor growls when it's running. So this must be connected. Some drives you can get away with without connecting frame ground to the motor, but on this system right here, it was sensitive enough that that motor, when I ran it, would growl. It didn't buck around, it just made a growling noise. Now let's go look at the feedback. Now, on this side, we have the servo drive connector labeled CN2 on the drive. On this side over here, we have the servo motor connector. The part number of this CN2 connector for my homemade feedback cable was 3M10120. 3M being the manufacturer and 10120 being the part number of that connector. So up here on pin 2 of the CN2 connector on the drive side is ground. On pin 4 of that CN2 connector we have 5 volts. That's 5 volts out of the drive and ground out of the drive to power up the feedback inside that servo motor. Now I'm using wires and socket pins without a connector. You need to be very, very, very careful when you do this with socket pins going into the servo motor. We don't want to get 5 volts on ground and ground on 5 volts. We don't want to get that backwards. That would destroy that feedback device inside that motor. Down here we have on pins 8 and 9 PS and PS bar. On our motor, that's not used. But this homemade cable is also used with other types of motors that do have that PS and PS bar connection to the servo motor. So I'm not using that, so I just left it slung off in the wind. Let's go down and look at the PA, PB, and PC connections. Again, this is the drive side, the servo drive side, 14, 15, 16, 17, 18, and 19 on connector CN2. And here are the pins on the servo motor side, E, F, A, B, C, D. So the PC and PC bar from the feedback, E and F, go to 14 and 15. PA and PA bar from the feedback into the drive are on pins A and B, and they go to 16 and 17 on the CN2 connector. PB and PB bar from the feedback are connected from C and D of the servo motor back into the servo drive on pin 18 and 19. And that's that. That's all I used. Well, it sounds simple when it's on paper, but when you start hooking all this up, it gets a little complicated. But that's it. That's all I used. Now, when you pull up the manual off the internet, you'll see that the CN1 connector has many more connections than what I used. You have an emulated encoder output, you have fault outputs, all kinds of different outputs, but the connections I showed you here are the only ones I needed to use to run that servo drive with that servo motor. There we go. It's been a pretty tough year around here, but right now that's all I want to say about that. Folks, enjoy the time with your families. Enjoy your time on this side of the dirt. Thank you very much for stopping by and seeing what we're working on next. And we'll see you next time.